Okay, to my new folks over in Ryland, I'm putting the website that our curriculum is found on in the chat. So if you go to the chat, that is where our curriculum is found. It's also found on the front page of our Google Classroom, right above the Meet link. There's a link that says Buzz. I'm going to show you this real quick. Uh, Here, I'll put this up on the screen as well for our new folks to log in at Buzz. Your login information is when you go to that website, there'll be a login and a password. And so, if this ever puts it up on the screen, the login information is right here at the bottom of the screen. Whatever your school email is, like this is Algorithm. That's one of my students, Algorithm. His email is Gorithm A at Bentonville K-12. So Gorithm A would be the login. So whatever your school email username is, don't put the Bentonville K-12 part, just the first part. And online 2026 is your password with a capital O, no spaces. But that is how you're going to log on to where our curriculum is found. Everybody else in here has already been logged in, so they're good. But that's just for my new folks so they can access our curriculum and be able to get into our class as we go about. Good to see you today. Hope you had a great Valentine's Day. I took my wife to the comedy club and saw a comedian who used to be an engineer, so all of his humor was like really nerdy. And he used a PowerPoint for his whole comedy presentation. It was hilarious. He even did a hexadecimal joke, which I really appreciated. With some of the people didn't laugh because I don't think they understood it. But hexadecimal is base 16. Our number system is base 10, right? You have the zeros, the ones column, the tens column, the hundreds column. Well, with hexadecimal, it's the zeros column, the 16s column, the 256 column, because it's based on this number 16. So he was saying, he says, hi, I'm 64, but that's only 40 in hexadecimal, which it is, because the 16 column would have 4 16s. I just laughed and laughed, but like I said, real nerdy humor. It was great. I loved it. So, all right, how we doing? Getting everybody in here? We got a lot of folks in here, but let's see. We're still missing like 5 people, but we're gonna have to get going. We're starting a new unit, so last week you should have the test done. If you don't have the test done, get the test done soon, because you want to get grades in at the end of this week. You'll have zeros if you haven't turned in the test. Now, if you've turned in the test, it's probably not been graded because it was just due Sunday night. Yesterday was a holiday. We didn't have school. I did not open my computer yesterday. I didn't go grade papers because I had the day off too. So today I opened it up and I saw I've got dozens of things to grade in Buzz, lots of tests and everything. So when you go to the grade screen, let's look at it together. So here's our Algebra 3 course in Buzz. We just finished the sequence and series, but let's go to the grade screen. I'm going to click on this little icon here and look at the grade screen in Buzz. Yes, you should have all of this completed from last unit. This weekend was the test. Oh, I did get it turned in. Look at there. I did get it on Friday. I got it turned in. And it may not be graded. So as long as it has a submitted date, that means you've turned it in and it's waiting on me. So I graded mine on Friday. But some of you may be graded if you turned it in earlier last week. If you waited till the weekend, I guarantee you it's not graded yet. The multiple choice part 1, that should be graded because that's done automatically by Buzz since it's multiple choice. But part 2 probably does not have a grade yet. So. Okay, let's scroll down and look at what this week holds. February 22nd is this Sunday, so this is what's due this week. We're going to get into our matrix operations, working with matrices. And this week we're going to look at matrix dimensions, matrix elements, and representing linear systems. And we're going to spend the next few weeks in this, till even right after spring break. So we're going to spend pretty much all of March and the rest of February looking at matrices and going through that good stuff. But this week is the dimensions, elements, and linear systems. So we'll have 3 assignments. Let me point this out before I go. Let's see. Let's go back to the activity screen. I'm going to close the Module 5 sequences and series. I've already opened the matrix stuff. But let me point this out while I'm thinking about it. This unit, and I got to say, in this class, man, a lot of people are doing great in this class. So you guys are nailing it. This unit is one where students usually, if they're struggling, raise their grade, because matrices, while some of it can be a little tricky, it's not hard as long as you're paying attention to the details. But the way I have it set up and the way we're going to do assignments is you can retake the assignment as many times as you want to, and you don't have to turn in your grade until the grade is what you want it to be. That's why students do so well this time. If you get a 50% on the assignment, don't turn it in, redo it. It doesn't take long. There's 4 questions on every assignment. 4. So if students get like 2 out of 4, it's like, well, I'm not going to turn that in. So they just go back and reopen the assignment until they get 4 out of 4. It's like, okay, now I'm going to turn it in. Look at me, I got 100%. So that's the great thing about the matrices and the way I have to set that. We're using Khan Academy for the matrix lessons and assignments. And so with Khan Academy, you can just go to Khan Academy and keep redoing it and not turn it until you're done. So if you were in my Algebra 2 class, we did some of this last year, but Algebra 3, we're getting farther into it. We did not spend as much time on it as we're going to in Algebra 3. We're going to get deeper into matrices than we did last year. But we're going to start off the first week or so reviewing what a matrix is and all that kind of good stuff. So with that, we're going to make sure we get logged in to Khan Academy this morning so that it keeps track of your score. Because if you forget to screenshot and turn in your score, you can go back and it will keep it for you. So let's look at what I'm talking about. What are you talking about, Mr. Brook? Starting the matrix unit. When you go to this in Buzz, it says we're using Khan Academy, and here's the link. All right, thanks, Peyton. Here is the link, and we're going to do, there's like 4 assessments and a final test. So what I want to do is I want to give a minute or two. I want everyone to log into Buzz and go click on this link under starting the matrix unit to make sure you're logged in to Khan Academy. So when you go here, it's going to have you log in if you're not already logged in, and it'll have you join my class if you've not already joined it. I did send an email last week to the class for anyone that was not already in Khan Academy. But you'll go here and you'll click join the Algebra 3 Mr. Brock class. But I'm going to pause for a minute, open up Buzz, go to the matrix unit in Buzz, go to the starting the matrix unit right there on the front page. When you go down to the bottom, starting the matrix unit, and you'll find that link. Find that link to Khan Academy. So just make sure you're logged in. Make sure it shows that you're in my class. All right, let's start through looking at what we're doing. We're doing these 3 assignments that's in the first 2 folders. Intro to matrices and representing linear systems of equations with augmented matrices. I may try to go back, reorganize this to put it in groups so you know exactly which folders are each week, but I haven't done that yet. But so what we're going to do in class today is we're going to go through this little video that shows us what matrices are and just the intro. We're going to go through the lesson that talks about that, and then we're going to look at these 2 assignments together as a class, and then we'll do the 3rd assignment today. And this won't take all class. This will be you'll have time to finish these assignments probably before you get to your advisory today. So let's take a look at that. Let's go to our first assignment here, our first lesson. Intro to matrices video. When I click on that, it's going to take me to Khan Academy, and it'll take me to this video. All right, here we go, guys.
What I want to do in this video is explore the notion of a matrix outside of the context of a surprisingly good movie that involves Keanu Reeves, and it's actually the first of three. I guess we could call the three movies combined the Matrices. And there is a relationship between the movie, which is about a virtual reality constructed by super smart computers, and the relation and the notion of what a matrix is when you study it in mathematics or when you study it in computer science. And the connection really is that matrices are used a lot when you are simulating things or when you're constructing things in computer science, especially in, frankly, computer graphics. So the super intelligent robots that made the matrix in the movie Matrix were probably using matrices in order to do it, if they actually did exist. Now, what is a matrix then? Well, that's a fairly simple answer. It's just a rectangular array of numbers. So, for example, this right over here, if I have 1, 0, -7, pi, 5, and, I don't know, 11. This is a matrix. This is a matrix where 1, 0, -7, pi, each of those are an entry in the matrix. This matrix right over here has two rows, and it has three columns. And because it has 2 rows and 3 columns, people will often say that this is a 2 by 3 matrix. Whenever they say it's a something by something matrix, they're telling you that it has 2 rows. So you see the 2 rows right over there, and they're telling you that it has 3 columns. You see the 3 columns right over there. I could give you other examples of a matrix. So I could have a 1 by 1 matrix. So I could have the matrix 1. This right over here is a 1 by 1 matrix. It has 1 row, 1 column. I could have a matrix like this: 3, 7, and 17. What is this? Well, this has 1 row. This is the 1 row we see here, and it has 3 columns. This is a 1 by 3 matrix. I could have a matrix, and I think you see where all of this is going. Figuring out the dimensions of a matrix are not too difficult. I could have a matrix that looks like this, where it's 3, 5, 0, 0, -1, -7. This 7, -7. This right over here has 3 rows. So it's 3 rows, and it has two columns. So we would call this a 3 by 2. Oh, let me do that in that same color. We would call it a 3 by 2 matrix. 3 rows and 2 columns. So fair enough. You know that a matrix is just a rectangular array of numbers. You can say what its dimensions are. You know that each of these numbers that take one of these positions, we just call those entries. But what are matrices good for? I still might not be clear what the connection is between this and this right over here. And at the most fundamental level, these are just ways, this is just a compact representation of a bunch of numbers. It's a way of representing information. They become very valuable in computer graphics because these numbers could represent the color intensity at a certain point. They could represent whether an object is there at a certain point. And as we develop an algebra around matrices, and when we talk about developing an algebra around matrices, we're going to talk about operations that we're going to perform on matrices that we would normally perform with numbers. So we're going to learn how, or we're going to essentially define how to multiply matrices, how to add matrices, how to we'll learn about taking an inverse of a matrix. And by coming up with an algebra of how we manipulate these things, it'll become very useful in the future when you're trying to write a computer graphics program, or you're trying to do an economic simulation or a probability simulation, to say, oh, I have this matrix that represents where different particles are in space, or I have this matrix that represents the state of some type of a game. And I know the algebra of matrices, and I know ways of doing it very efficiently so that I can multiply a bunch of them, or I could run a simulation, and I can actually come up with useful results. So that's all matrices are, but as you'll see through this, we can define operations on them. And then later on, when you take a linear algebra course in college, you'll learn a lot more of the depth of how they can be applied and what you can use them to represent.
All right, so a matrix is simply a way to group numbers and put them, all these numbers that are related to one another in some fashion, and we'll see more of that going forward. But it has the square brackets, and it has rows of numbers and columns of numbers. And so that's the basic thing you need to get from that, is how many rows and columns is how it's defined. If it's a 2 by 3 matrix, that means there are 2 rows of numbers and there's 3 columns. Those two rows are divided into three columns. You know, if it's a 4 by 5, it's 4 rows of 5 columns of numbers. So rows is always first. Think about if you're reading something, how many rows are there? That's the first number. And then the columns would be, we'll read all this column, read all this column, that type of thing. So that's our first thing. Now we're going to go through the lesson, which covers that as well. And I'm going to turn on the chat here in a minute because you're going to have some class participation to see if we can get these answers right and make sure we're understanding properly what this is. So, okay, let's go back here. All right, we got a little green check mark. We've done the video. Now let's look at the Intro to Matrices lesson. Click on that. It'll take us back to Khan Academy. This is where you can verify that you're logged in, because when it takes you back here, it should have your name up in the top right corner when it loads. There it is, Mr. Brock. I'm logged in. This is just a little menu on the side. We can close that because I want to have this whole screen here. Okay, our lesson is Intro to Matrices. So a matrix is a rectangular arrangement of numbers in rows and columns. So here is matrix A, and we generally name a matrix using a letter, A, B, C, D, capital letters. So this is matrix A, and we can see there are 2 rows of numbers, and each of those rows have 3 columns, and there's 3 numbers in each row. So we have 3 separate columns. So when we talk about the matrix dimensions, that tells the size of the matrix, the number of rows and columns in that order. That's the important part. The rows are first. Rows, then columns. So since matrix A has 2 rows and 3 columns, we write it as a 2 by 3. It's a 2 by 3. There are 2 rows, 3 columns. In contrast, here's matrix B. It's a 3 by 2. See, it has 3 rows of numbers with just 2 columns. So you can see the difference between a 2 by 3 and a 3 by 2. So when working with matrix dimensions, remember rows and columns. So let's try this right here. Do I have this? I can make this a little bigger. What are the dimensions of matrix D? Let me open up the chat. Put that in the chat. All right, got in the chat. 1, 2. I've seen a lot of people saying 4 by 3, 4 by 3. Yeah, count the rows. 1, 2, 3, 4. There are 4 rows, and there are 3 columns. Check. We get the green check mark. All right, good job. How about this one? This one we have to type in. All right, let's see what you got. I see 2 by 4, 2 by 5. I see a lot of people putting 2 by 4. Let's hope that's right. No, good job, guys. It is a 2 by 4. So what are the dimensions of this? Oh, this looks a little different. 3 by 1, 3 by, this is not going to trick you guys up. Yeah, there are 3 rows. 1, 2, 3, 3 rows. But there's only 1 column in numbers. That's pretty simple. 3 by 1, 3. Check. That's absolutely correct. Let's see. Oh, the next part let's talk about. We can talk about the individual numbers inside the matrix, and we can name those. And we name those by the position they're in. Like, let's look at matrix G here. We've got 3 rows and 3 columns. And if we talk about the element G, G tells us which matrix we're looking in, 2, 1. 2, 1. Now, this is in the same order that we do the dimensions in. The row is first and the column is second. So if we're looking at the element 2, 1, that means go to the second row, which is in blue. That's the second row. Go to the first column, which is there in brown. And which element are we talking about? Well, in this case, G2, 1 is the number 18, because that is the element that is in the second row and is the first column. So if we look at this one, in general, IJ, denoted as IJ. So let's check to see how we can do here. If we have matrix A, and we want to know what is A 1, 3, which element do we need to type in here? What element is 1, 3? Summers on it quickly. Looks like everyone's agreeing. Everyone likes number 8. Yes, 1 comma 3 would be the first row with the third column. So that would be the 8. Very good. Very good. How about this one? B2 comma 1. This is only a 2 by 2 matrix, smaller matrix. But which element is B2 comma 1? All right. I see a lot of folks saying 4.6, so I hope we're right. Absolutely. Good job, guys. Oh, I like this question here. I need to make this smaller so you can see all the choices. Okay, this says matrix C is a 2 by 3 and C1 comma 2 is 6. So which of these 4 is this describing? It's a 2 by 3 and C1 comma 2 equals 6. Is it A, B, C, or D? I'm seeing some C, some D. Oh, C. Just change this D to a C. All right, all right. Yeah, when we look at it, the first thing we have to see is which ones are 2 by 3 matrices, right? Which ones are 2 by 3 matrices? Well, A and B are both 3 by 2. 3 by T. Okay, I get you, Simmer. You're good. 3 by 2. So both of these can be eliminated immediately because they do not meet the right dimensions. It's a 2 by 3, not a 3 by 2. So then we have to look to see in position 1 comma 2 between these two, first row. So this one's in 2 comma 1. It's the opposite, right? So it is C. So like B had 1 comma 2 as a 6, but it's the wrong size. So let's check that. Absolutely, you guys are right. It is C. And that's the end of that lesson. All right. Okay, we just did the intro to matrices lesson. Now we have the first 2 assignments. And let me show you how these assignments work. And like I said, if you're in my classes last year, you probably remember this. But here is a link to the assignment. And when you make sure you're logged in, and then here's where we're going to turn in our score. Just scroll down. It's on the same page down at the bottom. This is what it looks like. When you click on this, this is what the assignment in Khan Academy is going to be. It's got 4 problems. Again, we can close this little menu on the side. Ready to practice. Show us what you can do. 4 questions. Down in the corner, we hit let's go. And the first question is, what are the dimensions of this matrix? And I make this big again. And what are the dimensions of this matrix right here? We got 4, 9, 8, -8, -4, 5, 9, 3, 7, -6. All right, what do you think? I don't think you guys are going to have any trouble this week. You're going to blow through these assignments quickly. How many rows? Remember, rows are first. There are 2 rows. How many columns? 1, 2, 3, 4, 5. There are 5 columns. When you hit check down here, say you do this problem. Oh, nice work. Keep going. Okay, so we got that one right. Next question. What are the dimensions of this matrix? Oh, look at that. We have an 8 and a -3. That's the entire matrix. So what are the dimensions? How do we classify this one? Rows and columns. All right, good job, everyone. Yeah, it's a 1 and a 2. It's a 1 by 2. 1 row, 2 columns. Very small, simple. 1 by 2. Let's turn that in. Nice work. Keep going. Next question. Okay, what are the dimensions of this matrix? We have a 3, a -6, and a -6. How many rows? How many columns? How many rows? How many columns? This one's kind of hard to mess up. If either way, you got 2 rows and 2 columns. So it's kind of hard to mess it up. It's a 2 either way. 2, 2. All right. Here's our last question. Ooh, this is a lot bigger. What are the dimensions of this final matrix right here? Rows and columns. This is kind of like the last one. Since they're the same number, it's hard to put the wrong one first. It's a 4-row, 4-column dimension. All right, now pay attention here. This is how you turn this assignment in Buzz. Good work. Show summary. Right here we see how did we do? Yay, we got 4 out of 4. So at this point, take a screenshot. I'm taking a screenshot like this. Just so it should have your name up in the corner and your score. Right. So I got the screenshot. There's my screenshot. I'm going to close this and go back to Buzz. And back here, I'm going to just paste my screenshot in there or attach it or however you need to do it. You can attach the file if you have to attach an image file, whatever. There it is. I got 4 out of 4 and I'm submitting my work right there. I've turned it in. Now, this is where I said students really helped their grade because maybe I didn't get 4 out of 4. Maybe I had rows and columns backwards a couple of times and I got 2 out of 4. Well, don't take a screenshot. Don't turn it in. Just close Khan Academy, click on the link, go back there again, and it'll give you 4 brand new problems, right? Now, if you were like, if you miss like the first 2 and then you quit, then when you take it back, it'll start you on question 3. So you have to finish the 4 before Khan lets you restart. So finish the 4, then close it and go back. So let's look at this real quick. What happens if I forgot to take a screenshot? Well, as long as you're logged in, that's not a problem. If I forgot, it's like, oh, I was supposed to turn it in Buzz. I can go back here, click on this link again. And since I'm logged in, it'll have my score right here on the left. That's a little thing. Look, oh, look, I got 100%. I got 100%. So I can take a screenshot of that where it shows I made 100%. I can turn that in. That's okay too. Because this is wanting me to start over. See, ready to practice? 4 more questions. Look, I got 100%, Mr. Park. Because I was logged in. It remembered that. That's good. All right, so we've done this assignment. Let's look. Matrix elements is our next assignment. So we'll look at that. Same situation. Click here. It's going to take us to Khan Academy to ready to practice 4 questions. I'm going to close this little thing on the side. Matrix elements. Which one is A4, 1? All right, what number are we typing in here? Plenty of numbers to choose from, folks. But only one of them is correct. So if we look to see 4, 1, that means we need to look at the 4th row. 1, 2, 3, 4. So that would be this row here. And we want the very first element, the first column. So the first element, the first column in row 4 is -5. Don't forget the negative. Good work. Keep going. Next question. 2, 3. We got a 4 by 5 matrix. We're looking for the 2, 3 element. So there's the first row. Here's the second row. 2, 9, -14, 4, -12. When I look for the third column, that's the first column. That's the second column. Oh, must be -14. Good job, guys. Check. Good work. You got it. Next question. 3, 4 for matrix A. 3, 4. First row, second row, third row. Oh, third row. That's what I want. And I want the 4th element, the 4th column. There it is. It's this. It's this one, not this one. Don't get the wrong one. I'm just kidding. Any one. It's a 1. That is a 1. Okay, last question. 5, 3. So this is a 5x4 matrix, and we want the fifth row, third column element. Well, that looks a lot like last one. Yeah, 1, 2, 3, 4, 5. The third element is a 1. Show summary. Yay, confetti once again. Okay, I'll take my screenshot. Ooh. Go down here. Yeah, thank you for the screenshot.
Yeah, make sure you haven't muted it.
Submit my work.
If it's not working,
Okay, that gets the intro to matrices folder. We're done with this folder. The other assignment, if we're not sure, we can go back to the grade screen and say, okay, how am I doing? Okay, I have submitted those two. They don't have a grade yet. I have to go put grades in for you. What's left? This one is due this week also, the representing linear systems with matrices. This one is next week, so we don't have to worry about this yet. Representing linear systems. So let's go back here. Representing linear systems. Let's look at the lesson, and then we'll do the assignment. Click Khan Academy. Here's the lesson. I'll close this little menu bar on the side. It always reminds us at the first. A matrix is a rectangular arrangement of numbers in the rows and columns. This is a 2x3. Representing a linear system with matrices. So a system of equations, which we did that back in the fall. I mean, we looked at it before. In Algebra 2, I know you looked at this. I don't know. Algebra 3, but we haven't spent much time on this. But we know what a system of equations is. You've got two equations that had the same variables, and you're trying to solve to find what x and what y would make both of these true. Well, we can use matrices to do that. So to convert these two equations into a matrix, we take just the coefficients. We don't need the x and the y. We don't need the equal sign, the plus, just the coefficients. So the first equation, the first row, we just use the numbers that are the coefficients. There's a 2, there's a 5, and there's a 10. So that establishes that this is the x column. All the coefficients for the x's will go in this column. The second equation has 3x, so it goes in the second row under the x column, 3x. There's 4 in the y column on the second row because there's a 4y in the equation. So we'll make that, I don't know why it shows making it bigger. That's not any bigger. And then the last column is the constants that the equations are equal to. Equals 10 equals 24. So the first equation and second equation. So you can see the first row represents the first equation. 2, 5, 10. The second row is the second equation. 3, 4, 24. All right. Any questions on that? Do we understand kind of how that matrix was created? Just looking at the coefficients, right? It color coded it to make it a little easier to see how that worked. You know, the x coefficients are green, and we put them in the same column. The y's are kind of a blue, we put those in the same column, and then these are brown, put those in the same column. So in an augmented matrix, each row represents one equation in the system. First row, second row, first equation, second equation. And each column represents a variable or the constant terms. So in this way, we can see that augmented matrices are a shorthand way of writing systems equations. It's kind of like a shortcut. This is quicker to write than this is. So the organization of numbers in the matrix makes it unnecessary to write like the x and the y and all that stuff. But it's still there. We can, if we understand this, we can read this. 2x plus 5y equals 10. All right, so this is another one of those which matrix, and there's only two choices this time. Here is our system of equations. 2x plus 3y equals 8, 5x plus 2y equals 2. A or B is the matrix that represents the systems of equation. The system of equations is A or B. What do you think? Because when you look at these two, the first row is the same, 2, 3, 8, 2, 3, 8. So that should match 2x, 3y equals 8. The second row is the only row that's different. It's either 2, 5, 2 or 5, 2, 2. That determines which one is correct. Well, we've got 5x and 2y. The x column is the first column. So the first column should have a 2 and a 5, 2 and a 5. This one has a 2 and a 2. This one has a 2 and a 5. So that's looking correct. Let's check the y's. 3 and 2 is the y column. 3 and 5, that's not correct. 3 and 2, that's correct. And 8 and 2, 8 and 2. Both of them have 8 and 2. So if we look at that, that is correct. Good job. The three of you that got that. This one we have to write ourselves. So looking at the first row, what are the three numbers that we need to put in our matrix to represent this systems of equation? This system of equations here. All right, Jaden's got an answer there. Let's see what everyone else got there. Livia's doing the whole thing, or Summers are doing the whole thing here. Then the X is a 7. The Y is a 4. What is the 3? It's just a 3. It's not a negative 3. Just take the number exactly like it is. Second row, 6, 3 Y's, and it equals 5. So since it equals 5, make sure you put the positive number 5 there. Check. Perfect. All right, let's look at another example. This gets a little bit trickier. It's not harder. It's just a little trickier. You got to pay a little more attention. If we have this system of equations, the system of equations is 3x minus 2y equals 4, x plus 5z. Oh, wait, we've got an xy up here. We got an xz here equals negative 3. And we got a negative 4x minus y plus 3z equals 0. So the first equation has an x and a y. The second equation has an x and a z. And the third one has an x, a y, and a z. So we really need to rewrite this because we have to use all of the variables in all of the equations in order to make a matrix. So we can take this and say, look, there's no z in this first one. Here, I'll make this a little smaller. We can see this at the same time. There's no z in this. It's 3x minus 2y, 3x minus 2y plus 0 z's. If we rewrite it like this, we've got all x's, all y's, and all z's. It just happens to be that the coefficient for the z in that first equation up there is a 0. That's why we skipped it and didn't write it when we wrote the equation. We have 0 z's. Well, that's fine. We got 0 m's, 0 r's, 0 s's, 0 t's. We didn't write any of those either. But the fact that the third equation has an x, y, and a z, we need to account for all the variables in each equation. So when we convert this to a matrix now, when we have an x column, we have the 3x, the 1x, and the negative 4x. We have all three. When we do the y column, see, this second equation didn't have a y. But in order to account for it, that means we have 0 y's. We rewrote that, having the 0 y. So we have 1x, 0 y's, and 5 z's equals negative 3. So negative 2, 0, and negative 1. The third column is our z column. Well, the first equation did not have a z, so it has 0 z's, but there are 5 and 3. And then we could just take whatever it equals, 4, negative 3, 0, 4, negative 3 zeros, whatever it equals. So now this represents all three equations and all of the variables in the constants. So again, notice how each column corresponds to a variable or the constants. And the numbers correspond to the coefficients in each equation. So looking at this system of equations, And this A and B is our choice of matrices. Which matrix is going to represent that system of equations? Now, if we look at the first row is the same in both of these. 3, -2, 1, 5, 10. 3, -2, 1, 5, 10. So that does not make a difference. It's the second row that makes a difference. We've got W plus 2y minus 4z equals 5. Which one of these is going to show that? Now pay attention. Which column, which variable is represented by the 3? Which variable is represented by the 2? Which variable is the 1 and the 5? And of course, we know the constants are 10, 5. That's the same in both of them. If the W is a 3, which it is, we see this must be the 3's column. We have a W in the second column, which is a 1. So 3 and 1 would be correct. Where 3 and 0, this says we do not have a W. Well, that's not correct. We do have a W. The second column, the -2, is the X column. We do not have an X in the second equation, so that would be 0. So absolutely A should be the correct. I know 3 of you are just going to nail this because you're answering every time, getting them right. Oh, we have to write this one. Okay, what's our first row going to be? Give me the numbers for the first row. Get big as I can again. Numbers for the first row. It's like, oh, wait a minute, Mr. Brock. I don't see many numbers. I see. They're there. They're there. They are there. They are there. So what is the coefficient of the A? The coefficient of the A, it has a negative out there. So it must be a -1 is the coefficient of the A. What about the coefficient of the B? Plus B. How many B's do we have? Well, 1, and it's positive. We had 1A, but it was a negative one. How about C's? We have a -2C. Negative. So there are -2 C's. We just take the number and whether it's positive or negative right here. And 12 is a positive number. All right. Try the second row. We've got 3A plus B equals -8. 3A plus B. What are the numbers that go in the second row? All right. Summer's got an answer out there. 3A plus B equals -8. So we know from the first equation that this is the A and the B and the C. A column, B column. We have to put these in the same order. So since A was -1, we have an A here that's a 3. B was 1. Oh, we have a B here also. It's 1. C is -2 C's. How many C's do we? We don't have any C's. We have 0 C's. And then we have -8. Ah, very nice. Oh, challenge problems. All right, let's see. I know some of you have been killing this. We're going to make it challenging. Challenging. I'm going to make this a little smaller to see everything at the time. Okay. Oh, I didn't mean to select that. Okay. Which system is represented by this matrix? We're going to do it the other way. I'm giving you the matrix, and you've got to put the equations. So here's the matrix. Which of these equations fit that matrix? Give you a moment to look at that. A or B? All right, Olivia's on it quickly there. So Soraya. We'll look and see if that's right in a moment. B, Summer, Jaden, everybody's go with the B. Xander. So looking at these equations, the second and third equations are the same in both choices. The 4x plus y plus z equals 2, and the 5x plus 2y minus 6. So those are the same. The only thing that's different is the very first equation. Negative 3x minus 5y equals 8, or negative 3y minus 5z equals 8. So the question is, are we using an x and a y, or a y and a z? Well, we have a 0 in this column here. Which variable is that? There's a 4 and a 5. Well, looking at the equations below, the 4 and the 5 are with the x. So the first equation must not have an x. It has a 0. Well, A has an x. B has a y and a z. This is the y, this is the z. So that is how it works out. Check. Perfect. We have one more sample challenge problem. Oh, gotta make it smaller. Gotta get all these on the screen here. Okay, here is the system up here. Here are the four choices. I'm gonna get some of you on this one. I'm just thinking that this one is the one that's gonna trick you. In fact, I'm writing this down on paper. I'm writing this down on paper. Well, I think I'm gonna catch a couple of y'all on this one. Got some choices out there. I'm seeing a lot of B's. Everyone thinking this is a B. Anyone think it's something else? Everyone gonna go with B? Nobody thinks it's something besides B. I'm just asking because B is wrong. So that's the only reason I'm asking. I just asked that because B is wrong. You're like, what? Heck, but Mr. Brock, well, let's explore this. We've got 3x plus 2 equals 12y, and we got negative 8y equals 2x plus 15. Well, we know when we make a matrix, all the x's are together in the same column, all the y's are in the same column, and then the constants are in the same column. We've got an x and a y, we've got a 2 and a 2x. These are not the same. They're in a different order. We have to make them all the same order, and we want the two variables on the left, and we want it to be equal to the number on the right. So let's take this first equation. 3x plus 2 equals 12y, and put that in the same order. So the 12y would need to move over to this side. So we subtract it, right? 3x minus 12y plus 2 equals 0 right now, but the 2 should be on that side. So let's subtract that. 3x minus 12y equals negative 2. Okay, that's what our equation would be if we rearrange it. We rearrange it to be in the right order. Let's look at this next one. Negative 8y equals 2x plus 15. Okay, the constant's already on the right, and the y is on the left, but the x is in the wrong place. Let's move it. And putting them in order, negative 2x minus 8y. We can't combine them because one's an x and one's a y, so they're separate. Now this is in the right order. Let's put it over here underneath the other one. So if we were to make that into a matrix, the x column would be 3 and negative 2. The y column would be negative 12 and negative 8, and the constant would be negative 2 and 15. This is what we're looking for. We had to rearrange them. Let's see which one of those looks like that. 3, negative 12, negative 2, negative 2. That's this one, right? C, 3, -12, -2, -2, -8, 15. It's actually C. Daniel was guessing that. Got to put them in the right order. Let's check that. That's it. Perfect. So yeah, that's a big thing in there. If you have systems of equations that are different, like these look different. Wait, we got an X and a Y over here and a Y over here, and just rewrite them. Get a pencil and paper and just make them the same. These are X and Y and a constant, X and Y and a constant. And then you can convert it to a matrix. That was the fooling thing, is that these are the wrong sign because they're on the wrong side of the equal sign. Once we move them to the other side, the sign changes. So I thought I might fool somebody on that one. Okay, that's the last one of that. So we're almost done with this. All we have left is this assignment that goes with the lesson we just looked at. Representing linear systems. Again, we turn this in down here. Once it opened up, I'm going to close that little tab on the side. Ready to practice. Yes. Write the following as an augmented matrix. All right, I can make this bigger again. Represent each row and column in the order in which the variables and equations appear below. X, Y, constant. X, Y, constant. So what goes in our blanks here? We have an X column, a Y column, and a constant column. So it's going to be 2, -3, -1. All right. 2, -3, -1. This is a positive. This is positive. So the bottom row is all positive numbers. 5, 2, 7. The X's are 2 and 5. Perfect. The Y's are -3 and 2. Perfect. The constants are -1 and a +7. Nice work. Okay, second question. Oh, there's 4 of them. I gotta make this smaller. Which of these 4 represents this system up here? Now notice here we've got an X, a Y, a Z, and a T. Here we've just got an X, a Z, and a T. Now since they put the T last, we'll keep the T last. We'll keep them the same. That's not alphabetical order, but that's the way that this equation is and this equation is. So that's fine. As long as we keep them in the same order, we can do the same thing down here. A, B, C, or D. Let's see. They're both a little different. I mean, all of them, none of them are the same on either row. Both row 1 is different in the different matrices. Row 2 is different in the different matrices because the second matrix is only a 2x4, where these are all 2x5s. So should this be a 2x4 or a 2x5? So let's see. Summer thinks it's D. I'll check that while we're getting other opinions. That was what our first response is. So let's see, 3x, so that would be our x column. 2y, that's our y column. 1z, so that's our z column. -7 and 1. So 3 of them have that same first row. So the key is the second row. 9x, well, there was a 3x, so it should be a 3, 9, 3, 9, 3, 9. 2y, but there's no y. So it's going to be a 2, 0, which puts us to B or D. 1z, -15z's, those are the same. -7t's, -8, those are the same. But this one, B, is missing the constants. It doesn't have the 1 and 13. It is D. Next question. Oh, we're going to write another one. They made this one easy on us. They gave us x and y in both equations. So this would be the x column, right? We'd have a 3 in this column and a 2 in this column. This would be the y column, a 1 here and a -2 here. And then just a 1 and a 0. I did those by columns instead of by rows. Just putting all the x's, putting all the y's, putting the constants. Okay, last question. Oh, this is another one that we're choosing. Which of these represents this? 9x plus 5z minus t equals 10. 12x plus 3y plus 2z minus 10t equals 4. So the first row is missing a y. Now look at this one as well. Look at the constants, 10 and 4. This one has 4 and 10, negative 4, negative 10, 10 and 4, negative 4. So they got the constants different in these equations. Summer's going to nail this assignment. She's got it. She's got to figure it out. What's missing? The y is missing. We do not have a y. 9x plus 5z minus t. Y is the second column. Looking at the second equation, x, y, z, t. So the second column of row 1 should have a 0. All these others have a y. Negative 1y, 5y, 1y. Great job. Show the summary. Take the screenshot. If I had my screenshot ready, I could have got the confetti in the screenshot, but I wasn't ready. Perfect. Okay, there's my screenshot. Submit my work. And we have done that. So if we go back and double check, yes, I've done everything that's due this Sunday, February 22nd. This is next week. We'll do 3 more next week. 3 assignments that are all 4 questions. And we've gone through and looked at those. Now, those still available. If you need to go back, it's like, wait a minute, I was confused on that element thing, Mr. Brock. That's fine. Go back and look at that again. Or get with me and say, I didn't quite get that. You know, if you struggle with any of this, go back and get the grade you want before you submit it. All right. Make sure you understand it to where, oh, I got 4 out of 4, man. I nailed this, Mr. Brock. Great. So, all right, guys, you've got the rest of the period. You can probably have these done well before advisory. You got 36 minutes till advisory. So I will give you the rest of the period. Rylan and Summer, hang around for a few minutes here. Let me just kind of talk about how everything, the transition works for you guys. Welcome to class. Glad you're here. But everyone else, you got it. Go get your assignments done and be wrapped up for the week.